Take GC solution. Our subject today is mathematics. Our topic today is trigonometry, which goes for the baccalaureate, part 1 and GC advanced level students. And trigonometry is actually, if you look at it keenly, we have trig, which means triangle, and nometry, which means measurement of triangle. For us to embark on our trigonometry today, we need to sketch our right angle triangle. A right angle triangle is simply an angle which sum of an angle of 180 degrees. So our right angle triangle and we name our angle which we are going to measure theta. We indicate our sides A, B, C. The longest side of the triangle, we name it the hypotenuse. The adjacent side to the angle, we describe it as the adjacent. And the side which is in front of the angle, we name it as the opposite side. Now we are going to look on our basic trigonometric identities. Basic trigonometric identities. Our basic trigonometric identities, which are sine theta of our angle, which simply means the opposite side on the hypotenuse, and cos theta of our angle, which is simply the adjacent on the hypotenuse. And we move to tan theta, which is simply the opposite on the adjacent. So these are our basic trigonometric identities which we are going to be using in trigonometry. Now we are going to replace our opposite, adjacent and hypotenuse by their sides. If you look, sine theta is simply the opposite, which is the opposite on the hypotenuse. The opposite side of this angle is AB, and the hypotenuse side of this angle is AC. So we are going to have AB on AC, and cos theta, which is simply adjacent on hypotenuse, is giving us BC on AC. So we are going to have BC on AC. Now we are going to look on the tan theta. So tan theta will simply be equals to, which is opposite on adjacent, this is the opposite side AB, and the adjacent side is BC. So we are going to have AB on BC. So these are our basic trigonometric identity which we are going to use further. Now we are going to apply what we call the Pythagoras theorem. The Pythagoras theorem This theorem simply states that the sum of the squared of the longest side of the triangle is equal to the sum of the squared of the opposite and the adjacent side of that triangle, which simply means that AC all that squared is equals to AB all that squared plus BC all that squared. So that's the Pythagoras theorem which we are going to apply to derive our first trigonometric identity. Now we are going to divide both sides by our hypotenuse. We are going to divide both sides by the longest side, AC all that squared divided by AC all that squared divided by AC all that squared. Here we are going to cancel, and we are going to have AB on AC all that squared plus B on AC all that squared equals to 1. Now we are going to substitute our trigonometric identities AB on AC, which is simply sine theta, and BC on AC, which is simply cos theta, to derive our first trigonometric identity. Now we are going to replace them by our basic trigonometric identity. We are going to have sine theta all that squared plus cos theta all that squared equals to 1, which simply implies we are going to have the sine squared theta plus cos squared theta equals to 1, which is our first trigonometric identity. Now, from this trigonometric identity, we are going to derive the other trigonometric identities by simply what? By either dividing both sides of the equation by sine theta, sine squared theta, or by dividing both sides of the equation by cos squared theta to derive the other two trigonometric identities. Now, let's divide both sides. Dividing both sides by sine squared theta. So we are going to simply have sine squared theta divided by sine squared theta plus cos squared theta divided by sine squared theta equals to 1 divided by sine squared theta. Our sine squared theta cancels with sine squared theta here, and we are going to have 1 plus cos squared theta on sine squared theta equals to 1 on sine squared theta. Considering the other basic trigonometric identities, we have sec theta, which is equal to 1 on tan theta, or cos theta on sin theta. We have our cosec theta, which is simply 1 on sin theta, and we have our cot theta, which is simply here we simply going to have a 1 on cos theta, and here we are going to have a cos theta on sin theta, or 1 on tan theta. So now we have our other basic trigonometric identity, which makes we have 6 basic trigonometric identities. Now we are going to use these other trigonometric identities to apply in our second trigonometric identity equation. So we are going to simply have 1 plus cos theta on sin theta all that squared equals to 1 on sin theta all that squared. So we are simply going to have 1 plus cos theta on sin theta is simply what? Cot theta. So we are going to have cot theta all that squared equals to 1 on sin theta is simply giving us what? Cosec theta. So we are going to have cosec theta all that squared. Simplifying our equation, we are going to have 1 plus cot squared theta equals to cosec squared theta. This is our equation 2 of our trigonometric identities. Now we move to the next trigonometric identities. We are simply going to have, by dividing both sides by cos squared theta, we are going to have sin squared theta divided by cos squared theta plus cos squared theta divided by cos squared theta equals to 1 divided by cos squared theta. Cos squared theta cancel, and we are going to have sin squared theta on cos squared theta plus 1 equals to 1 on cos squared theta. Now we are going to rearrange in order to substitute our basic trigonometric identity. Cos sin theta on cos theta all that squared plus 1 equals to 1 on cos theta all that squared. Now sin theta on cos theta is simply tan theta, which is A on B, which is opposite side on BC, which we can represent as sin theta on equals theta. Now we can take our trigonometric identity and substitute in our equation. We are going to have tan theta all that squared plus 1 equals to sec theta all that squared. Now we are going to have tan squared theta plus 1 equals to sec squared theta. This is our equation 3 of our trigonometric identities. Now we can try a GC equation with these basic trigonometric identities.